Pascal's principle is pretty straightforward. Um, and and that's really simply that if you add pressure anywhere in a fluid, you've added it everywhere. And so if I add pressure here on this system by pushing down here, then that same pressure gets added there, right? And here's the thing, it's pressure, not force we're talking about, it's pressure. So if I add 10 newtons of pressure here, and this area over here is twice the area there, then that same 10 newtons per unit area is added over here, which means my 10 newtons over here becomes 20 newtons over here. And so this is how we use hydraulics and pistons to transmit pressure and generate a lot of force somewhere else. It's kind of like a lever, right? In fact, the math is exactly the same as that for levers that we studied in statics. So let's look at, let's look at that here. So here we have P1, all right, is F1 over A1, that's 100 pascals. Okay. F2 then, which is twice as big, F2 is then 200 newtons, right? So we've got 100 newtons becoming 200 newtons. Um, if you move the first piston, it's like this is how levers work, right? If I move the first piston 0.1 meters, how far does the second piston move? Well, you work through it, it moves only 0.05 meters. So you work through all the math and you begin to see how this works. Okay, it multiplies the force, but the amount of work I do is the same. And so when you think about brakes, let's think about a brake system. You've got a brake pedal here, and that pushes on a cylinder. So you got a master brake cylinder. And this combines a lot of things that you've been studying. So you got a brake, and you're going to push on the brake there. And the hinge on the brake is up here, and it actually pushes on the cylinder from down here. So you've got a lever arm on the brake already. Great. You got a lever arm on the brake. And that pushes on this cylinder that's fairly large in terms of volume. And then you've got your hydraulic tubes that go to your brakes, and it pushes on your brakes, which are typically disc brakes on either side now. We don't use drum brakes much anymore. And they need to move just a little bitty bit, right? They're not moving much at all. You're moving a lot here. You're moving just a little bit there. You're generating not a lot of force here with your foot as you push down. You're generating enough force here to bring a car to a stop, to stop that spinning wheel. Can you imagine trying to grab the disc on your disc brakes with your fingers and bring the car to a stop? Um, and so this is the basic principle behind hydraulics is we're going to use motion of fluid, the multiplying effect we can get from area and the increase in force we can get to move this piece just a little bit. And that just a little bit is enough to take it from not touching your disc on your disc brakes to clamping down on your disc brakes really hard and using friction to bring your car to a stop. So that's the basics behind hydraulics. We're going to write it slightly differently. All right, so P1, one thing to think about, P1 equals P2. The pressures are the same. That means F1 over A1, and this is the basic of what you need to get. F1 over A1 is equal to F2, if I could write an F, over A2. And those are the basics of Pascal's principle, and kind of get you to where everything you need to know about how to solve problems involving hydraulics.